So I'm delighted to be here today. This is a really lovely opportunity, and I've enjoyed all of the presentations so far, and I'm going to build on them in a number of different ways in my own talk. The title of my talk is What's Awe Got to Do with It? And of course, that's a riff on a Tina Turner song, What's Love Got to Do with It, right? In that song, she questions whether love is really important at all for relationships and for the human experience, and it's intended to be ironic. The answer is clearly yes, love is very important, and yet when I started out as a graduate student working with Dacher 20 years ago, what I realized was that people were bringing that same skepticism to the table when they talked about awe. There was literally no empirical research on awe. Emotion researchers, even in casual conversations, seem to have very little interest in it. And even when talking with friends, people outside of academia, it was like awe was some kind of emotional luxury item. It was the affective equivalent of a BMW or a Gucci handbag, right? Great if you have the opportunity, but not anything fundamental. It's not part of our food and drink. It's not the air that we breathe as human beings. Albert Einstein had a very, very different perspective on this. In Living Philosophies, in one of his essays, he wrote that awe is the most beautiful thing that we can experience, the source of all true art and science. He described the person who could no longer experience wonder and awe as good as dead. So I'm going to make a case that Einstein was right today and present some science as well as another perspective that I hope will convince you of that. I think we've got a lot of folks who are already on board with that already, but I'm going to present you some data that I think supports that general idea. This is the definition of awe that we use in the work that I've been doing, that we started doing many years ago in Dacher's lab. And it pulls on a lot of the themes that we've already discussed today. We define awe as an emotional response to physically or conceptually extraordinary stimuli that challenge our normal day-to-day frame of reference and are not already integrated into our understanding of the world. And in the first study that I did with Dacher back in the late 90s, asking about awe, it's the first, to our knowledge, first empirical study of awe, we simply asked people, can you tell us about a time that you felt awe, and really write about that in detail? What was happening, what was going on, what was in front of you, and why did you feel awe? There were certain kinds of stimuli that people talked about all the time, right? They talked about panoramic nature views that they'd seen from a high place. They talked about extraordinary sunrises and sunsets that just sort of shocked them out of their day-to-day experience of just what the sky is supposed to look like. Experiences incredible weather phenomena like the northern lights are certainly high up there. But we can also talk about human-made awe-inspiring phenomena as well. So people talked about extraordinary pieces of architecture that they were seeing for the first time. Paintings or other works of art, it could be music, it could be dance, but works of art that really sort of challenged the way that they understand the world and sort of reshaped the way that they think about what's going on around them. The human body is capable of extraordinary feats as well. These are two performers from Cirque Du Soleil. Cirque Du Soleil tickets go on for a couple $100 a pop now, depending on which show you're talking about in Las Vegas. So this is clearly something people are willing to invest time and resources in experiencing. So the question that we come back to is, why? What is it that awe's doing for us that we find so valuable? And how should that shape the way that we seek out and integrate awe into our lives? I'm going to answer that question from two different perspectives today, wearing two different hats that are really important to me in my life, and Dacher actually alluded to both of them. So the first is the perspective of a scientist. From that perspective, I think of awe, and our research suggests that awe is a constellation of effects that help us take in large amounts of information from the environment, changing how we process and think about and understand the world around us. But then I'm going to switch hats and talk about awe as a fundamental aspect of the human experience that really enriches our sense of meaning in life. So let's start with the first hat. This is the control room in my lab. This is my graduate student, Claire Yee. She's looking at some physiological data that's coming in through the computer from two participants you can see in that little tiny screen on the right. As a scientist, I'm particularly interested in the question of mechanisms. So if what awe does is alter the way that we process information, see the world, and think about what's going on out there around us, how exactly does it do that? And we've addressed that question in 3 different ways. We've looked at the subjective experience of awe. What does awe feel like, and what are people thinking about? What is their phenomenology when they're in an awe state? We've also looked in the lab at the physiological effects of awe. I'm going to tell you about a study that picked up on that today. And then we've done a number of studies, most recently, this is work funded by the John Templeton Foundation, looking at the effects of awe on some pretty subtle cognitive processes, and I'm going to share 2 experiments with you today that really dug into that. So let's start with this issue of the subjective experience of awe. I've already told you about the first study that I did in Dakkar's lab when we were asking people just to tell us about a time we felt awe. Based on those narratives, we asked a number of more specific questions and asked people to rate specific thoughts that they might have had, or specific feelings or ways of relating to the world around them that they might have had during an awe experience. So we randomly assigned a bunch of participants either to tell us about a time when they saw a particular panoramic view for the first time, and in that condition people said they felt lots of awe. It was above 6 on a 7-point scale. And we randomly assigned another group of participants to tell us about an accomplishment that was really important to them, and the primary emotion there was pride. Here's what we found. Relative to pride, in an awe state, people talk about feeling really small and insignificant. This theme has come up a number of times today, that you're in the presence of something greater than the self, and your own day-to-day concerns are not really on your radar screen right now. But this is not necessarily an unpleasant experience. People actually described this as very positive, normatively. People felt connected with the world around them. They didn't want the experience to end. And what's really striking for us about this is that this is happening, but it's actually very relaxing for people, right? It's rather than being challenging or tiring, it's very soothing and calming. So this aspect of the phenomenology of awe is something we wanted to carry forward into some of the subsequent questions that we asked. Now, one of the things that stands out about emotion is that it's often experienced as very arousing, right? Very activating. And that's true for negative emotions, but it's also often true for positive emotions. So in some follow-up work, we actually wanted to get into the lab and find out what the physiological effects of awe might look like. So since I got to Arizona State University, we have set up a psychophysiology lab, and I routinely bring folks in and slap a bunch of sensors on their torso and hands and try not to make it too awkward or creepy. And place people in front of emotional stimuli and try to get a sense of what their physical responses look like. Their physical responses tell us a little bit about what kind of behavior any given emotion state might be geared toward promoting. And when you feel your heart pounding, right, and your hands starting to sweat, your blood pressure goes up, that's your body getting ready for physical activity. Well, that's kind of a funny state for awe, right? When you think about an awe experience, you don't think about getting ready to run around a whole lot. You just kind of think about being still. So we wanted to be able to compare awe to other kinds of emotions. Now, when you think about positive emotion, and when I started work as a faculty member at ASU, the vast majority of the research on the physiology of emotion looked at negative emotions. And not all negative emotions look exactly the same. There are some subtle but important differences. But as a general rule, if you think about the last time you were really scared, right, what are some of the sensations that come to mind? Your hands might get really cold, right? You might start to sweat a little bit. You might feel your heart pounding harder. Your mouth might get dry, right? Your stomach might start to get some butterflies. These changes are all mediated by the sympathetic branch of the nervous system. It's part of the nervous system that extends from your brain and your spinal cord all the way out to the organs and the fingertips of your body. It's often referred to as the fight-flight branch of the body. We can contrast that with what's often referred to as the rest and digest, right, branch of the autonomic nervous system. I love this picture. Tell me you don't feel like that after Thanksgiving dinner, right? Okay, that response that I've just had this big, huge meal and I'm just gonna chill out now, right, is your body's effort to digest the food that you just ate. It can't do that while you're running around. So your body has these two systems that help to maintain trade-offs between physical activity on the sympathetic side and growth and digestion processes on the parasympathetic side. Now, these are not mutually exclusive, and in introductory psychology textbooks, how many of you took an intro-psych class at some point? Okay. How many of those of you who did, learned that the sympathetic and parasympathetic balance is like a switch that goes on and off? Was it described that way? Okay, it's a very common description that you see in intro psychology classes. It's inaccurate, though, because really they're both active all the time, and they're kind of playing off against each other and constantly adjusting to both react to what you're doing, but also anticipate your body's needs to maintain homeostasis. And the result, in some cases, is some really, really interesting patterns. So, for instance, sex, right? In order to become aroused, the parasympathetic branch of the autonomic nervous system needs to be somewhat cranked up, right? In the sense that you're relaxed, you're calm. This is why stress is so problematic for sexual activity, right? So in order to get an erection, in order to become aroused, both for men and women, parasympathetic activity needs to be fairly high. And it is actually fairly high in most of us most of the time. It's usually kind of the default setting. Over the course of arousal, sympathetic activation comes up to meet it, right? So your heart rate increases, you start to sweat, you start all those feelings that we associate with physical activity. That grows and grows and grows and grows. Orgasm, boom, they both drop. Okay, and a friend of mine who studies sexual activity in the lab, believe it or not, as well as Masters and Johnson, have documented this effect, and it's a very, very striking one. So how do we measure the activation of these systems in the lab? Well, the most common measure, physiological measure of emotion that people use is heart rate. It's a little complicated, though, because it's influenced by both fight, flight, and rest and digest activation, right? Sympathetic nervous system raises your heart rate, the other one brings it down. So it's a little murky, right, exactly what's going on. If we really want to pick up on fight, flight activation, we've got some other measures at our disposal. And the one that I'm going to focus on is this top one, cardiac pre ejection period. So if you think of the heart within every beat as contracting, right? Cardiac pre ejection period is how quickly or slowly the muscle contracts. If it contracts really quickly, what happens to the blood? Right? It's a lot of pressure. It's putting a lot of pressure on the blood, so it goes shooting out of the system in a really efficient way. If that's mellower, okay, this is a little more like what your heart's doing if you're more relaxed. The blood's still getting out of there, it's just not in quite as much of a hurry. Okay. So cardiac pre-ejection, when it's really short, like this, is an indicator of very high sympathetic nervous system activity, and it's one that we're really interested in. We can contrast that with activation in the parasympathetic branch, and we usually measure this by something that you might have heard of, referred to as vagal tone, heart rate variability. We use a particular index called respiratory sinus arrhythmia. And you can feel this right now. So take two of your fingers, okay? Put them on the inside of your wrist, right next to your thumb, so that you can feel your heartbeat. Y'all got that? You can feel your pulse? Close your eyes. Take a few slow, deep breaths. You notice anything? Okay. If you're reasonably relaxed, what you may have noticed is that when you breathe in, your heart rate speeds up. And when you breathe out, it slows down again. This is not only normal, it's very healthy. Respiratory, breathing, sinus, period, arrhythmia, change in rhythm that goes with your breathing for your heart, has been linked to higher emotion regulation capability, higher overall self-regulation ability, higher dispositional positive emotionality, lots of good stuff. And it's an indicator that the parasympathetic branch of the nervous system is particularly active right now. Okay, so as I said, when I first got to ASU, most of the research on the physiology of emotion emphasized negative emotions, and we really wanted to know what happens in different positive emotions in the body. We brought people into the lab and we exposed people to, we hooked them up to a bunch of sensors, and we exposed them to sets of images that were intended to target specific emotions. And I'm going to focus on a couple of these today. We had some neutral ones. We always want to compare to those because the body reacts to neutral stimuli and we want to be able to reference against that. So we had simple household objects. In the enthusiasm condition, which is the one I'm going to use as a reference point to see what another positive emotion looks like today, we showed people these lottery slides, right? So in the first slide, they see their own lottery numbers. And then in the subsequent slide, they see little balls pop up. And each of those balls indicates that they're going to win more money. Now, these are undergrads at ASU, so they're like, come on, $10, yes! So funny, cleaning the data, I didn't know which trial I was cleaning, but I could literally see when it was this one, because they're like skin conductance, they would sweat every time a new slide came on. It was great. And we had a bunch of other conditions too. In the interest of time, I'm not going to focus on that today, but for all, we showed a bunch of really beautiful, wide, vividly colored panoramic views. Okay. What did that lottery slide set look like? We saw full-blown fight-flight sympathetic nervous system activation. It was great. People's heart rate went up, they started to sweat, their blood pressure went up, and this index of respiratory sinus of parasympathetic activation, respiratory sinus arrhythmia, went down. This is a body that's getting ready for action. Whatever it is that they're seeing, whether it's like a rabbit that they want to have for dinner or some sort of financial reward, their bodies are getting ready to go after it. This is the sign of a body that's getting ready to move. What do we see in awe? Well, we saw a couple of really interesting things. The first is that we saw a reduction in fight-flight sympathetic nervous system influence on the heart. So the heart was just doing this. And this is a change from baseline. We measure it right before we start showing them these pictures. And it went from kind of being like this to being like, it's much more mellowed out. But this is the interesting thing. We also saw a reduction in parasympathetic activation. So both sympathetic and parasympathetic activation went down. And we were kind of like, that's weird. Haven't seen that a whole lot in emotion research, except sex, right after orgasm. And I was talking about this recently with a colleague of mine who studies physiological responses during physical activity. And he said, you see the same thing when people are working really hard. Their sympathetic system's cranked up so they can move, but their parasympathetic's cranked up to regulate that too. And when they suddenly stop, boom, they both drop. Just like someone in this situation who probably worked pretty damn hard to get up there. Yeah? And is now stopping. One thing that we know is that arousal makes it difficult to take in large amounts of information from the environment. When we're aroused, whether it's because of emotion or physiological activity, we have a tendency to hone in on something really specific and concentrate on that thing. It makes it difficult to do what you really need to do in this situation or want to do in this situation, which is take all of it in. And I'm going to come back to that when I talk about, next, some physiological effects of emotion. Cognitive effects of emotion. And that's where we have been working and focusing for the last couple of years. So what's really interesting about this is the contrast between awe and most other positive emotions. For decades now, hundreds of studies have found that when people are in a positive mood, they get a little sloppy cognitively. It's very efficient because what they're doing is they're using their existing knowledge to filter and frame their interpretation of what's going on around them. They're relying on what they already know. And a lot of the time that actually makes sense. Like, we bother to learn information because it's going to help us later. And positive mood seems to facilitate that. But one consequence is that we're relying a lot on heuristics or shortcuts when we're processing new information. And we see things like an increased reliance on what we call the fundamental attribution error, right? Attributing others' behavior to their personality rather than the situation. Bless you. Increased use of stereotyping. An increased focus on the gist of information rather than particular details of what you're hearing or seeing. And I'm going to talk about some implications for persuasion shortly. Now, what links all of these things together is this sort of bumper sticker mentality. It's not that it's wrong. It's just that it's a really, really kind of oversimplified way of interpreting and perceiving what might actually be a quite complicated phenomenon. So we've started doing a bunch of studies asking whether awe is fundamentally different from that. So here's one kind of study that we did. If you're in this study, what you do is you come into the lab and we do an emotion induction. In our awe condition, we had people watch a video called The Powers of 10, right? And then we have them listen to a 5-minute audio story about going out to a romantic dinner. Now, if I say romantic dinner, what's the image that comes into your mind? Right, candles on the table, right? She might be wearing a dress, he might be wearing a tie. There are probably flowers, the mood's kind of dim. But you've got this image that's got a fair amount of detail based upon your prior experience with romantic dinners. Well, we're telling them a 5-minute story that has a whole bunch of details, but we specifically left out some things that you might expect, like there's not actually a candle on the table. What's really interesting is that when people are just generally in a happy mood in previous research, if you do this and then you ask them later, hey, was there a candle on the table? People in a happy mood are more likely to say, yeah, there was, even if there wasn't, than people in a neutral mood or a sad mood. So they're imposing their own mental image of a romantic dinner onto this actual situation. Well, we thought the opposite should happen for awe, and we wanted to check that out. So we brought participants into the lab. We did precisely that. And here's what we found. So these are accuracy scores. So these are how well people did on items where the question we're asking them is something like, was there a candle on the table? It's very appropriate for the prototypical romantic dinner, but the correct answer is no. What we found is that people in the awe condition did better than people in a general positive emotion condition and better than those in a neutral condition. In a follow-up study, we found that this differentiated it from a bunch of other positive emotions as well as neutral. And in a third study, we found that this effect generalized to emotions like an awe-fear blend and admiration or elevation. This is this emotional response to the extraordinary actions of another person. So that was fun. That was work with my current graduate student, Alex Danvers. In work with a prior graduate student, Vladis Griškevičius, we were interested in applying a paradigm that's been used a lot to look at the effects of positive emotion on how we process persuasive messages. So if you were in ASU in this study, you came into the lab, and we asked you to remember a particular experience really vividly that elicited a particular positive emotion or a neutral control condition. And then we tried to convince you with an article that had 9 arguments in it that ASU should start a new policy where in order to graduate, you have to pass a senior oral comprehensive exam. And you've got to pass that exam before you can graduate. Now, how do you think ASU students feel about this? They hate this idea, right? So we can reasonably infer that if they agree with it, it's because we've convinced them. Now, what was interesting about this is that as this is a pretty common paradigm in social psychology research on persuasion, half of the participants saw 9 good arguments. Things like, when universities implement this, their students are more likely to get jobs afterwards, they're more likely to be paid better, so there are really good consequences of having this policy. The other half of the participants heard 9 weak arguments, things like, well, the university president's daughter thinks this is a great idea. Who cares, right? So someone who's actually paying attention and processing this carefully should show a big difference between whether they saw the good arguments or the bad ones, right? Someone who's being like, 9 is great, we like 9, right, is going to be persuaded by the arguments no matter what. Here's what we saw. In the neutral condition, we just use this as a reference point, folks who were exposed to the strong arguments were more persuaded than folks who were exposed to the weak arguments, right? That's a pretty standard finding, but it's not a huge effect. For most positive emotions, people were really easily convinced whether they were seeing the strong arguments or the crappy ones. They were like, 9, that's good, I'm in. Here's what happened with awe. Right, that really accentuated this careful processing. If they were reading good arguments, they were very convinced. If they were reading bad arguments, they were like, I don't think so. No, I don't buy it. So they were much more vigilant about the quality of the information that they were being presented with. So when we put all this together, we think we've got some pretty good evidence for how and why awe might change the way that we see the world. We've got a lot more work to do, But so far, what we've learned is that the subjective feeling of awe is very pleasant, it's calming, and that it pulls our attention away from the self and toward the world around us. From a physiological standpoint, awe seems to produce a reduction in both fight, flight, and rest and digest activation that looks similar to the cessation of intense movement and may support taking in more information from the world around us. And then finally, in our most recent work, we found that awe seems to reduce our tendency to filter our current experience through what we think we already know. And that's really important for a lot of the reasons that we've been talking about, that tendency to knock us out of our day-to-day experience of the world and open up the opportunity to see the world in a new way. So in the last couple minutes that I have left, I'm going to talk about awe and why I think we have awe and what we can do with it and what it means for us in a more personal way. This is my hat as an artist. So since childhood, I've been very seriously involved in music and dance and in the theater. So when I got to graduate school and found out that no one, and I mean no one, was doing empirical research on awe, I was shocked. I was like, how can you study emotion and not be interested in this? I don't get it. But it took me a while to realize that as an artist, you come at this from a kind of a unique perspective, but that it could be valuable, because I was sort of thinking about, well, what is it about artistic stimuli that draw this response from us? And there's so many different ways that the arts can evoke awe in us. This has become my standard answer. I frequently am asked by scientists as well as in interviews, well, isn't awe such an unusual experience? Isn't it so rare that it can't really serve much purpose? I'm like, what are you talking about? We have awe stimuli all around us. There's like, I keep looking at this little thing of Japanese maple on the table. I'm like, there's an awe stimulus right there. I don't know about that thing about smell, but have you ever smelled a stargazer lily? Those things are pretty frickin' impressive. The arts are tailor-made to elicit awe. They are novel. They are very complicated in many cases. They're accessible, though. They're patterned. And when that many people today have talked about patterns, and it's your brain trying to figure out and take in as much information as it can about this new thing that you're looking at and figure out how to put it together in something that you can use later on. Now, sometimes that is literally vast, as in the Sistine Chapel. Sometimes the vastness is more metaphorical, though. So this is Picasso's Guernica, right, which is an attempt to convey the enormity of a historical event pictorially in a way that you can't really do just with words alone, at least not in the way that he wanted to be able to express it. We see boundary breaking with the physical body as well. A single dancer can do things with the body that challenge our notion of what the human body can do. And in doing that, they challenge our notion of what a single human being can do in other domains as well. As a group, dancers can create patterns working together that are not only beautiful in their own right, and vividly compelling for our attention in their own right, but remind us of what groups of people can do together as well. Music is a prototypical awe stimulus. It is novel when you hear it for the first few times. It is inherently complicated and designed typically to start with a simple theme and elaborate on that theme to become more and more complex, and layered and patterned in ways that are very, very sophisticated. Even the human voice, and a number of people have talked about that today, and we heard an absolutely beautiful rendition and example of how compelling and awe-inspiring the voice can be from Melanie earlier today, right? Has a really interesting property. The human voice is tonal. When we speak, when we sing, ah, okay, it's a tone. And a tone is defined by, you can sort of see it visually over here. For any given tone, there's a single frequency that we call the fundamental frequency, but that's not it. So if you hear a C on a piano, say, you're hearing a C, but you're also hearing a bunch of higher notes that are geometric divisions of the fundamental frequency that you heard. So you're actually, when you hear a single tone, you're hearing a chord. You just don't realize it. So a harmony, for instance, a C, right, an E, and a G that sounds harmonic and pleasant, is by definition a series of tones where the harmonics overlap each other, right? So even a single tone can be incredibly complicated. Music is complicated in other ways as well. I wanted to be able to play a bunch of these for you, but there's obviously no way we're going to do that in the time. Just take a picture. They're all on, They're all on iTunes, go for it. But music is complicated and awe-inspiring in so many ways. It's very common practice for a song to begin with a simple theme. We alluded to Rachmaninoff earlier, right? Variations on a Theme by Paganini. Starts with a simple theme and then builds and builds and builds and builds, and it becomes increasingly complicated, challenging and pushing that theme as it moves on. Happens in all different kinds of music. You can use harmony, right? Notes layered on each other that work together well and then push each other in different directions. We can use rounds. You guys sang a round earlier today, right, where you have one theme that starts with different individuals or different instruments at different times and builds in that way to add complexity. You can have layering of different instruments and tracks on top of each other. And one thing to notice here is this is not just classical music. I'm pulling from all different genres of music here. Rock, musical theater, I'm a disco girl, right? Never downplay the complexity of Donna Summer's music. It's actually incredibly complicated music. You just gotta know what you're listening for. 9 Inch Nails, right? If you got a strong stomach for off-color lyrics, that's a phenomenal song. It's an incredibly complicated song. You don't even need music per se, right? Patterns of rhythm and rhyme and rap are designed to evoke this same sense of complexity. Your mind's trying to keep up with the complexity of what's being thrown at it and fit it into a patterned whole. And you can even, with a single note, play with the notes in a way that elicits awe. Go listen to this song by the Goo Goo Dolls, Black Balloon. I actually heard it in the car on the way in this morning. That was great. In the beginning of the song, what you hear is a sequence of notes where the harmonics have been distorted. It sounds tinny. I see a few of you nodding. You know what I'm talking about, right? And what that does is it makes it really difficult to figure out what key the song's in until the first full chord comes in and tells you, and it's not what you're expecting. It's a wonderful movement. Carlos Santana's live version of Europa. How many of you know this song? Okay, good number of you. Go check it out if not. There's one note that he holds on that guitar for several bars. And over the course of that several bars, he's playing with the note. He's actually changing the way that one note sounds in a way that's absolutely spectacular, and why that one particular version of that song has been so popular over time. So I'm just going to leave you with a little more personal note. This is me in Las Vegas, believe it or not, Red Rocks. This picture was taken on the afternoon when I had found out that morning that a very close friend of mine from college was dying. She'd been fighting lung cancer for about a year, and she'd been doing so well, but we found out the day beforehand that she'd been put in hospice, and when she was non-responsive the next morning, we knew that it was, that she didn't have long. So I had to get out of Vegas, right? This is the only place that I could go and sort of get a sense that the world was bigger than her, than me, than us, and what we were going through. And that night I went to a Santana concert, which really had the same effect. And that might seem a little weird to some folks, like your friend was dying and you were at a Santana concert in Vegas. I couldn't think of any place else to be. Because when I think about what art is, it's notoriously difficult to define. But I think what it's doing is it's taking these formal properties of complexity and novelty and harmony, whether it's literal auditory harmony or visual harmony, right, to create an awe state in us that's receptive to the details of new information while throwing at us the intensity of someone else's lived experience. It's their vision of the world as they've seen it. And in part of being exposed to that, we not only take in someone else's experience in a way that we might not be able to if we were more defended, the usual defended state that we walk through the world in, but we become part of that. We become part of that greater universe. And the experience that we're feeling becomes our own experience, and we're connected to it in a much greater way. So that sense of being small and insignificant that I talked about earlier actually becomes a really precious thing in this context. So thanks again to the Greater Good Science Center for putting this together today. You're going to hear more in some additional talks today about the importance of awe for our connectedness with others and how it's experienced throughout the world, and some of the further talks this afternoon. In closing, I just want to thank my collaborators, both in the scientific work that we've been doing, but also some of the artistic work that I've been doing for the last few years. Thanks so much.